We're going to look at a couple of different momentum problems right now. And the first type here is the most basic one when we just are working with individual objects. So question A says, which object has more momentum? A 13 kilogram object traveling at 2.3 meters per second, or a 9.0 kilogram object traveling at negative 4.1 meters per second. So our most basic formula for momentum is P equals m times v. So I need to take the mass times their velocities. So object number 1 here has a mass of 13 kilograms. And the velocity is 2.3 meters per second. So when I multiply those two together, 13 times 2.3, I end up getting a momentum of 29.9, there we go, kilogram meter per second. Okay, now object number 2 is 9 kilograms traveling at negative 4. So again, I will use the same formula, 9.0 kilograms traveling at negative 4.1 meters per second. Multiply those together. And for object number 2, I get a momentum of negative 36.9 kilogram meters per second. Now, as far as which object has more momentum, it would end up being object 2. Sometimes people will get thrown off by the negative sign, and the negative is just indicating the direction that the momentum is going. So essentially, these objects are rolling in opposite directions from each other. So the negative here is just saying that we have 36.9 kilogram meters per second rolling to the left versus object number 1 had 29.9 kilogram meters per second, but it was going to the right. So object number 2 actually would have more momentum. Okay, question B. This time we're going to be looking at two objects colliding, and we're going to have a completely elastic collision, which means there's no deformation, no heat generated. The balls just bounce off each other, what we would call cleanly. All right, so a 3 kilogram ball is rolling to the right at 2 meters per second, and a different 4 kilogram ball is rolling to the left at 2.5 meters per second. So those values right there are the initial values. Okay, after the balls collide, the first ball is rolling to the left at 4 meters per second. How fast and in what direction is the second ball moving? So that second sentence is giving us the after the collision values. Now, when we're working with these problems, we are going to be working with the conservation of momentum. So our momentum before has to be equal to the momentum after. So I'm going to call the momentum before the initial momentum, and it is the sum of the individual values. So our first one, we have a 3 kilogram ball rolling to the right. So we're going to assume right is positive at 2 meters per second. So ball number 1 has a momentum. We're just going to leave it as 6 kilogram meters per second right now. Okay, ball number 2 is 4 kilograms. Oops, I didn't use my labels on the last one. I won't here. And it's rolling to the left at 2.5. So that is a negative. Make sure you get that negative in there. Okay, so this is ball number 2. And if you take 4 times your negative 2.5, you're going to end up with negative 10 for the momentum of ball number 2. And again, those are both initial values. Okay, so the sum of my initial values, I would take 6 plus negative 10, and that's going to be the initial total momentum of my system. I'm going to just leave it like that for a second. Now, my final values. Okay, so after the ball collides, the first ball is still going to be 3 kilograms, and it is rolling to the left at 4 meters per second. So that would be a negative 4, which would give me a momentum of negative 12. Okay, now ball number 2 is our unknown. Well, we still know that ball number 2 is 4 kilograms, but we don't know how fast it's going. Okay, so ball number 2's momentum would be called 4x. Now, again, the final momentum is the sum of my parts. So I would add these two together. I would end up with negative 12 plus 4x, and that would be my final. Now, with our conservation of momentum, my initial and my final have to be equal to each other. So I end up with this equation that I can solve using algebra. So 6 plus negative 10 gives me negative 4. And on the right-hand side, I still have negative 12 plus 4x. I would need to add 12 to both sides in order to get rid of the minus 12. That will cancel those two out. That leaves me with 8 here and 4v. And then to get rid of the timesing by 4, I would need to divide both sides by 4, divide both sides by 4, and that cancels out. 8 divided by 4 is 2. So it looks like the velocity of that second ball would be 2 meters per second. Let's check our significant figures. It looks like I only get one significant figure, so I need to put my label in there. And that second ball is rolling 2 meters per second, and then in what direction? So because our answer turned out to be positive, it would be rolling to the right. Okay, if our answer had turned out to be negative, it would have been rolling to the left. So that's one way to set it up. Another way that a lot of people use, it's the exact same process actually, but it's just set up all in one formula, so it doesn't take up quite as much room. But again, you would need to decide what makes sense for you. So we could set this up as 3 times 2 plus our 4 kilogram rolling to the left at negative 2.5. And then because of our conservation of momentum, that has to be equal to the after values. So the first ball rolling to the left, and the second ball is 4 kilograms and it's unknown. So it's still actually the exact same individual components, but it's all just written down in one formula. When you solve this out, you will get the exact same answer. So if this formula doesn't make sense to you, you might want to try solving it the other way, where you kind of piece it out just one object at a time. Okay, now for this next one, we're going to do it as a completely inelastic. So completely inelastic means that the objects are going to stick together when they collide. So we're still going to have a conservation of momentum, but our setup's going to look a little differently. So it says, let's use the question above. What would be the final speed and direction if the two initial balls collided and then stuck together? So our initial values are still going to be the same. That's not going to change. So that was 6 plus a negative 10. And that gave us a negative 4 for the initial. Okay, now the final part, this is where it's a little bit different. So because our objects are sticking together, they are going to be moving at the same velocity, but the mass isn't just going to be one of their masses. So my mass, because I'm still using P equals mv, so my mass is going to be the sum of the masses. So the 3 kilogram ball is now stuck to the 4 kilogram ball. So they are going to act together as one mass. So it's like having a single 7 kilogram mass, because 3 plus 4 is 7, and they'll be moving at the same velocity. So now on my formula, my left-hand side is still the negative 4 I computed earlier, but now my right-hand side is just going to be 7v. So I can solve that equation. Negative 4 is equal to 7v. Using some algebra, divide by 7, divide by 7. those will cancel out on the right-hand side. And then when I take -4 divided by 7, I'm going to end up with v equals -0.571, etc. Again, I only get one significant figure, so I would put in my velocity as -0.6 meters per second. And then let me go back and check. Okay, so the speed and direction. So the speed is 0.6 meters per second, and the direction, because it's a negative, is to the left. So that would actually be my final answer. That is supposed to say left, L-E-F-T. Okay, so two types of collisions there. One of them, they bounced off from each other, and the other one, they stuck together. So you have to think about how those objects are interacting. And then the last one for this particular topic, dealing with momentum, was the idea of impulse. So impulse is essentially the change of momentum. Now, in this situation, a 5-kilogram ball is rolling towards a wall at 4 meters per second. When it strikes the wall, it rebounds with a speed of 3 meters per second. What's the impulse? So our ball here has an initial momentum. Let's see, 5 kilograms. All right, so anyhow, our 5 kilograms is rolling at 4 meters per second. So let's assume that the ball is rolling to the right at 4 meters per second. We'll make that positive. Okay, so our initial momentum is going to be 20 kilogram meters per second is our initial momentum. Now, when it strikes the wall, it rebounds with a speed of 3 meters per second. Now here, the rebound indicates that it's going in the opposite direction, so its velocity would actually be -3 meters per second. Well, the mass of the ball doesn't change, so we would take 5 times -3, and we have a -15 kilogram meters per second. I left off my slash over in the other one there. And this would be our final momentum. So our impulse is the change in that amount of momentum. So to find the change in any value, we take the later value, so in this case it would be the -15, and we minus the earlier value, which would be 20. And we would have a change of -35 kilogram meters per second.